Hello all of you. After the maths and physics videos, I have decided to move on to past papers. I am starting with the very first paper, first year 13 paper or first A-level paper for the specification, which is the one belonging to June 2017. There is one for June 2016 also, but that is the AS papers. So I'm starting with the June 2017 papers. First, I will be doing the multiple choice questions. So let's start with the first question. We are going to do multiple choice questions. Which of the following is a correct unit for gravitational field strength? So it has just said units. It hasn't said anything specifically like base units, then gravitational field strength. So our starting point should be the equation for gravitational field strength, which is force experienced by unit mass, and then let's put down the units of these two quantities here, Newton and kilogram. So Newton per kilogram. Then we can check if we have that as one of the options. Yes, we do. So the answer is B. You have seen the second question before. You have seen this when we were doing the materials test, I think. So for materials A, B, C, D, they have the same length and cross-sectional area. So the force against the extension is given in the diagram. Which material is brittle and which has the greatest ultimate tensile strength? So brittle, what does brittle mean? The graph should stop immediately at the elastic limit. So you have two such ones here which stops immediately at the elastic limit, but then it has to satisfy one more thing, greatest ultimate tensile strength, which means it will be able to withstand more force. So you can see that among A and B, B can withstand a greater value of force. So our answer for that would be B. Moving on to question 3, they're saying the braking distance of a car is directly proportional to its initial kinetic energy. The braking distance of a car is 18 meters when the initial speed is 10 meters per second. What is the braking distance of the car when the initial speed is 25 meters per second? So the first line says the braking distance is directly proportional. So D is directly proportional to the initial kinetic energy, which means D is proportional to half mv square. The car is the same, so that tells us that this is a constant, which means anyway half is also a constant. So which means we can say that the distance is proportional to the square of the speed. So d1 over d2 is equal to v1 square over v2 square. t1 is given as 18 meters, so 18 divided by the second braking distance is what you have to find. v1 square is 10 square and v2 square is 25 square. So if you rearrange this, you will get the value as 112.5, which is the same as 113. So answer is C. Okay, now moving on to the fourth question. So a ball is dropped from rest above the ground. Air resistance has negligible effect. The speed of the ball is v after it has fallen a distance h. Which graph is correct for this falling ball? There are actually two ways in which you can do it. So let's assume that all the gravitational potential energy is going to be converted into kinetic energy, assuming there is no air resistance. Mass and mass gets cancelled. G is a constant, half is a constant. So it basically tells you that h is proportional to v square, or h is directly proportional to v square. So h and v square have to be directly proportional. And what does the shape of a directly proportional graph look like? It's a straight line passing through 0, 0. So the answer has to be A. Then I said there is another way also in which you can do this. For example, we can use one of the equations of motion. Starting from rest means u is 0, isn't it? V square equals u square plus 2as. U is 0. You can see v square is equal to 2as. It is going to fall under gravity, so this is a constant. 2 is anyway a constant, so we again reach v square is proportional to s, which is the distance fallen. So v square is proportional to h. So we ended up getting the same relation using two different methods. So our answer here is A. So now question number 5. Which is the best estimate of the area of a rectangular field of length this much and width this much? So basically they are just asking us for the area and the uncertainty. So again, there are two ways in which you can do this. First, anyway, I have to find out the area. So length is 98. So area is 98 times 47, which is going to be 4606. Okay, and then length is plus or minus 3. So I'm going to find the percentage uncertainty in the length. Percentage uncertainty in length will be 3 divided by 98 times 100, which is 3.06, and percentage uncertainty in width is going to be 2 divided by 47 times 100, and that is going to be 4.25. So the total percentage uncertainty is going to be 3.06 plus 4.25, which is 7.31. We can't stop there. We have to find out the 7.31 percentage of the total area. So 7.31% of our total area is 4606. So if you find that out, you will get it as 337 meters square. So the final answer is actually this much plus 337 meters square. But then the area, if you look at the actual area, should have only two significant figures. So 4600 plus or minus. The uncertainties are having only one significant figures, 3 and 2, one significant figure. So that makes it 300 meter square. So the answer has to be D. I know some of you are not comfortable writing it this way. In that case, for those who are not comfortable writing it that way, there is another way you can do it. So you can always go for the maximum and minimum values. So the maximum length is going to be 101 meter, and the minimum length is going to be 95 meters. Then maximum width is going to be 49 meters, and minimum width is going to be 45 meters. Area doesn't change. Area doesn't change.